In Lesson 1, we built a new project with a basic UI backed with mock data. In this lesson, we'll hook Sunshine up with the cloud, replacing the mock data with real weather data using the Open Weather Map API. To do that, we'll learn about the Android permission system, network I/O, and how to move time-consuming tasks off the main UI thread.
On that note, we're going to make our Sunshine app 100 times better now by connecting it over the network to the Open Weather Map service. Open Weather Map provides a free weather data and forecast API, and the site is linked below so you can follow along. By scrolling through the site, you can see what type of data is available. It also has example queries, so you can click on this one to see what the weather is like in London. It includes a user-friendly description of the weather condition, such as broken clouds in this case. And we'll use this later in our app. For the full list of weather conditions, you can go back to the main page and scroll down, and then click on this link here for the weather condition codes. And on this page, we have the full list of weather conditions. It contains everything from scattered clouds to freezing rain, or even volcanic ash. I don't know about you, but hopefully that doesn't happen too often. Take a moment now to become familiar with the API by going back to the main page and looking at the different queries and the different parameters supported. Just modify the query params in the URL address bar. Check the box floating in the clouds when you're done. Now we should be able to figure out the most appropriate URL that our app should use. Based on the UX wireframes that we saw earlier, you'll notice that we'll want 1 week's worth of data. For this quiz and for the example code that we'll be showing you later, we're going to be using the postal code for Mountain View, which is 94043. By all means, you should use your own location, either specifying the postal code, city name, or the latitude-longitude coordinates. Next, we want the format from the server to be in JSON format, and we want the units to be reported in metric. But our UI will be able to display Celsius or Fahrenheit based on user preferences, and we'll just do the conversion ourselves. Enter the URL that fulfills these requirements in the box below. For the Mountain View postcode 94043, this is what the query would look like. We set the mode to be JSON format, temperature units to be in metric, and the count param to be 7 days of forecast data. Let's take this URL and use it in our app. To fetch the data from Open Weather Map within our app, first we need to make an HTTP request to the API at the URL that we decided on earlier. Then we need to read the response from the input stream to get a JSON string. It hasn't been parsed yet, but we'll worry about that later. Then we clean up by disconnecting the connection and closing any input streams. We also log any errors that we catch. Since it's a lot of networking boilerplate code, we provided you with a code snippet that handles these steps. See the link for the GitHub gist below. After you've taken a look at it, check this box to continue. In the sample code provided, you'll notice that we create an HTTP URL connection. To use HTTP to send and receive data over the network, we have 2 clients on Android, the HTTP URL connection class, as well as Apache HTTP client class. Both options support HTTPS, streaming uploads and downloads, configurable timeouts, IPv6, and connection pooling. We recommend the HTTP URL connection class because it's general purpose and lightweight, and it's been optimized to suit the needs of most Android apps. To learn more about connecting to the network, see the training guide and blog post linked below. You'll also notice in the sample code that we have lines that call log.e, which log error messages. With the ADB command line tool and with the device plugged in, you can type ADB logcat to see the debug and error messages that are being printed to the logcat. For more details on the logcat options, see the link below. Another way to view the logs is to use Android Studio. If you click on this green Android button, it launches the Android Device Monitor, which includes the DDMS tool that Beto mentioned earlier. Then click on a device and you can see that our app here is a running process. If you click on the Logcat tab, then you see all these log messages here, which is what we saw with ADB Logcat. Now try viewing the logs yourself with either of those methods. If you do both, then you get brownie points. Check this box to proceed. When you're logging a message in your app, you need to determine what log level it should be displayed at. Verbose logs should never be compiled into your app except during development. Debug logs are compiled in, but they're stripped out at runtime. Error, warn, and info logs are all kept. And this is what the logging API looks like. The first parameter is the log tag, which can be any string that you want to identify the log message. It's good practice to define the log tag as a constant in your class. Usually it's the name of your class or the app. The second parameter is the actual log message. If we go back to monitor, we can see that this is the log tag column, and this is where the log message is. If you click on this drop-down here, you can filter the logs by log level. For example, you can click on error to see all the error messages. If you click on warn, you'll see all the warning messages as well as anything more severe than that. The same goes for the other levels, and verbose means that you can see all the logs at all log levels. As a pro tip, you should avoid log spam for your sake and the sake of other developers. The log buffer could fill up, and important error messages that you really need to see will either roll off the logs or it will get lost in a sea of unimportant log messages. Cool, now that we know we can use logging to help us debug our app, we're going to return to this networking code snippet here and drop it into the Sunshine app to query for actual weather data. Open up your project to mainActivity.java. In this class, scroll down to the placeholder fragment class. Within the placeholder fragment class, in the onCreateView method, scroll down and go ahead and add the networking code snippet here. The GitHub link is pasted below again if you need it. You may need to enable these options in auto import or add the imports manually. See the instructions below. When you run the app, you'll see that it crashes. Use logcat to figure out which error is the guilty culprit that caused the crash. We're assuming that for this quiz question, you're using a device that's running Honeycomb or later. Use the emulator if needed. If you run it on your phone, your app will crash because of a network on main thread exception. We found this answer by connecting our device to our computer and then checking Android Device Monitor for the error. You can see here that this is our app package name and this is our process ID. If you search the logs for that process ID, then our error appears. It's triggered ultimately by a network on main thread exception. If you're curious as to what line of our code actually caused this, you can scroll down the stack trace to read more. This is all framework code that you can skip, and here's where it actually hits our app. It's within the placeholder fragment class in the onCreateView method, and it happens in mainActivity.java file in line 116. So if we go back to the code, on that line you can see that URL connection.connect actually caused the error and that we can't do that on the main thread. When we said that the framework didn't want us to run network operations on the main thread, what is the main thread? Well, Android apps run by default on the main thread, also called the UI thread. It handles all the user input as well as the output, such as screen drawing. Thus, we want to avoid any time-consuming operations here, otherwise the UI is going to stutter. Instead, kick off a background worker thread if you have to do some long-running work. This includes doing network calls, decoding bitmaps, or reading and writing from the database. Okay, so somehow we have to move the networking code off the main thread, but how are we going to do that? Well, there are several options, but let's look for the name of the Android class that simplifies background thread creation and UI thread synchronization, so that the results from the background work will come back onto the main thread, and then we can use it to update our UI. Search online and figure out the answer to this question, and then enter the class name in the box. Here's some advice for you. If you ever get stuck on how to do something in Android, and you can't find it on the developer site, you can try to check stackoverflow.com. It's a question and answer site that many Android developers use as a valuable resource, so chances are likely that someone already has asked a similar question that you have. If you answered async task, then you're correct. To understand why we chose async task as the answer, we can check the developer documentation. In this API guide on processes and threads, we can scroll to the worker threads section. By the way, if you want to follow along, the link is included below. Say, for example, that you want to download an image from the network at this URL, and then you want to update the UI so that it displays this bitmap. Well, creating your own thread to download the image is a valid option, but there's a lot of overhead to handle in making your app actually thread safe. After you download your image, you cannot directly update the UI from a background thread. However, Android has several options to run code that manipulates the UI from other threads. In this example, yet another runnable is created to get the bitmap result back onto the main thread to update the image view. This solution is a little cumbersome because you have to manage two runnables here. To abstract away this complexity, we can use an async task. And then to kick off the async task, for example, when someone clicks a button, then you just initialize the task, and then you can call execute on it, and then pass in any parameters that are needed. Notice that when you're extending the async class, there's a couple of generics that you need to specify. The first is the type that will be passed into the doInBackground method. So if you want to pass in this image URL, then you specify string here, and then in doInBackground, you'll get a string parameter. The second one is for the type of object that you'll get when you get progress updates as the task gets executed. We're not using that here, so it's okay to specify that as void. And the third type is type of result that we'll be sending back to the main thread through the onPostExecute method. The main advantage of the async task is that you get to focus on your app logic, what you need to do on the background thread, and what you need to do when it comes back to the main thread. You don't have to worry about the details of threads and handlers. Of the methods that I showed you, only doInBackground is required to be implemented. OnPostExecute is optional, as well as some other methods. For each method, tell us whether it's on the main or background thread. You have a 50% chance of getting each one correct, or 100% if you actually go check the Java doc, so go do that now. In the documentation for async task, we can scroll down to the section that talks about protected methods. Here we see that different methods are called on the UI thread versus on the background thread. It also contains information on what order these methods are called in relative to the doInBackground method. For example, onPreExecute gets called on the UI thread before doInBackground. So with that information, now we can populate the answers to our quiz. As we mentioned before, onPreExecute happens on the main thread, and here you can do any setup work. Then doInBackground happens on the background thread. While this is running, you can actually call publish progress as many times as you want so that you can pass information to the UI so that it can update and then tell the user that a certain percentage of the work is done. Each time this is called, it triggers onProgressUpdate with some information. Then you can show a loading indicator in your UI that says something's 10% done, 50% done, 100% done, and all this happens on the main thread. And then once all of this is complete in the background thread, then it calls onPostExecute with the results on the main thread. Let's apply what we just learned by opening up the mainActivity.java file within our project. We're going to take this networking code snippet and move it over to its own async task so it runs on a background thread. The task is going to be defined within this fragment class. But speaking of which, it's actually still called placeholder fragment. Let's do a little bit of refactoring now by giving it a real name. Let's call it forecast fragment. And then you can update it in other appropriate places as well. We can also move forecast fragment into its own file. That way the main activity won't get so long and cumbersome. Within forecast fragment, we should define a new inner class called fetchWeatherTask, which extends from async task. And then you can move the networking code snippet here. After you make the changes and run your app, it should look something like this. There really should be no difference, except it doesn't crash now. In the next step, we'll add code to execute the task, and later in the lesson, we'll do JSON parsing and updating the UI. In the meantime, though, make these initial changes to your code. For the solution, within forecast fragment, we implemented fetchWeatherTask, which extends async task. The generics we use are just void, and this is fine for now. Then within the doInBackground method, we copied our networking code snippet here. It's the same, except that in certain cases, we return null instead of setting the forecast JSON string to be null. Previously, the code was in onCreateView, which expected us to inflate and return a view, so it's important that it got to the rest of the code, even if there was an error in the networking code. Now that the networking code is an async task, there's really nothing that comes after this in the doInBackground method, so it's fine to just bail early whenever there's an error. Also note that for our log messages, we've defined a log tag constant at the top of this task. This log tag is defined to be the name of the fetchWeatherTask class. The reason we use this syntax instead of declaring a string fetchWeatherTask is because we want these two to be in sync. If you ever rename the class, then it will throw an exception unless you also update it here. As we mentioned before, you're going to still see fake data in the app. We'll need to add code to actually kick off a background task from the main thread. For debugging purposes, it would be nice if we could execute the task anytime we wanted by interacting with the UI somehow. So we're going to add a refresh menu option for debugging. Warning though, this menu option should not ship in the final app.
Before we go any further, I need to jump in here. Catherine's already said that the refresh button is for debugging only, but let's look at why. In real life, you should always seek to eliminate the refresh button from your app. A good app should work like a good butler, giving you what you want before you even have to ask for it. Much like the save button, it's a relic of a bygone age that's at best a reassuring safety blanket for those of us who grew up with floppy disks. With the ability to run background tasks or send messages directly from the server to our app, there's really no reason to force users to manually hit refresh. That the app is up to date and synced with the cloud should be a given. But like we said, this is for debugging, so like printline, it's acceptable for this particular purpose. But let's also take a look at our background threading model. Which of the following is potentially an issue? Well, the transfer isn't happening on the UI thread, but that's not a bad thing. In fact, it's good that it's not happening on the UI thread, so that's not a problem either. Data transfers are an integral part of most modern smartphone apps, so that's not a problem. The real problem is that the transfer is happening on a thread whose lifetime is tied explicitly to a UI component, in this case an activity. So if the activity is terminated by something like a screen rotation, the transfer will also be terminated. Because it's being created within an activity, it can be terminated as simply as rotating the phone into a different orientation. So should only ever be used for tasks whose life cycle is tied to the host activity and is expected to run for only a second or two. On mobile, it's unwise to assume that even the most trivial network access is going to happen quickly, so a better approach would be to use a service. An application component without a UI that's less likely to be interrupted, possibly scheduled using an inexact repeating alarm. Even better, Android has a specialized solution known as a sync adapter, and it's designed especially to schedule your background data syncs as efficiently as possible. Better still would be using Google Cloud Messaging. This lets you notify your sync adapter of changes on the server side, so you're only ever initiating network requests from your app when you know there's something to be updated on the server. For now, we're concentrating on making our app work when it's in the foreground, but we'll return to look at these approaches to invisibly updating your app from the background a little later. For now, keep in mind that the refresh button and the new thread solution is just a placeholder while we hook up the rest of the app.
Thanks, Rado. With that in mind, let's add a refresh menu button to our app. For temporary purposes only though, otherwise Rado would be mad at us. On Android, menu options are defined in XML, and they can be declared for fragments or activities. When the fragment or activity is created, it inflates this XML into the actual menu items in the app. You'll see that there are action buttons, which are menu items that appear in the action bar, such as this search menu item. This space is reserved for the most prominent actions in your app. Then anything else that's less important falls into the overflow menu by tapping on this button with the 3 dots. These menu items are ordered from most frequently used to least frequently used. And on larger devices that have more screen real estate, you can specify that some of these menu items can actually go into the action bar if there's room. If you go back to our project, in the resources folder, which is called res, there's a menu folder, and inside that, there's the main.xml file. If you open that up, you see the menu layout XML and that there's a single menu option defined for settings. It will never show up as an action in the action bar, meaning that it will be in the overflow menu. You can verify this by checking the app on your phone. To define the ordering of menu items, you can just add multiple items to this XML file and then they'll show up in that order in the app. If you don't like the order though, and you want to explicitly set it, then you can specify this order in category value Right now it's set as 100 so that the settings menu will be at the bottom of all the other menu options that we define in our app. The only menu option that should show up below the settings menu is the help menu. Check out the link for more details. Since the fetch weather task is in the fragment, the menu option to trigger that task should also be in the fragment. That means we should create a new menu layout, and we'll call it forecastfragment.xml. Inside that, we'll declare the new menu item with this ID. At the end, when you run your app, it should look something like this. You'll also need to define a string label for this word. See how the menu main.xml file is implemented as an example. For an additional hint, see the menu training guide linked below. When you're done, you can click on this box here. Here's the code for the refresh button in the forecast fragment menu XML file. We want it to appear in the overflow menu, so we set show as action as never. We also declare the string. You can find the string here in the strings.xml file, which is located in the values folder, which is in the reds folder. You can get your strings.xml file translated into different languages. This adds additional values folders under res. For example, you would have values-es for Spanish, values-fr for French, and within each of those values folders, you would have a strings.xml file, which would contain the localized strings for that language. Since translation does cost money, as a pro tip, you can mark strings that you don't need translated using translatable equals false. For example, if it's a proper name or if it's for debugging like this one, then you can indicate to the translator that they can skip over these strings. Now that we have the menu XML, add the code in the fragment to inflate it. You can leave a placeholder for when the refresh button is selected. This is what it should look like when you're done. You should see the refresh menu item there, but tapping on it doesn't do anything. That's fine for now. If needed, you can look at mainactivity.java for reference. If you get stuck and don't see the menu item appear, try to answer this question first. What fragment method do you need to call in order to report that it has menu options to display? The solution is that we need to call fragment.setHasOptionsMenu true. That way we'll get appropriate options menu callback methods in the fragment so that we can inflate the menu and for when a menu item is selected. And this is the code where the fragment inflates the menu. First, in the onCreate method, we call setHasOptionsMenu to be true. This means that we'll get these callback methods later. In onCreateOptionsMenu, we inflate the menu XML that we defined earlier. We also get callbacks when a menu item is selected. When the menu item with ID action refresh is called, we simply return true for now. Now modify the code so that when the refresh menu item is selected, it executes the fetch weather task. But hang on, when you tap on the refresh button, it actually crashes. Why don't you go check the logs to see what error is causing this? In the forecast fragment class, we modify the onOptionsItemSelected method. When the refresh menu item is selected, we create a new fetch weather task and then we call execute on it. While the call is no longer blocking the UI thread because it's an async task, the app will still crash. If we check the logs, we see that the app crashed, this time though with a security exception. It says permission denied and asks if you're missing the internet permission or not. And indeed, we are missing the internet permission, so we need to request it.
Let's talk about permissions. When each app APK is installed, it's given its own unique Linux user ID, and each app runs within its own instance of the Android virtual machine. As a result, each app is completely sandboxed. Its files, processes, and other resources are inaccessible to other apps. This sandboxing approach is used to ensure that by default, no app can access sensitive data or perform actions that could adversely impact other apps, the OS, or users. Things like accessing the internet, getting a user's location, or reading or modifying the contacts database. Rather than asking the user each time an app tries to access something sensitive, you declare the permissions that your app requires in its manifest. You can get a list of all of the permissions your app may require here at the Android developer site. So why not just ask for all the permissions and never worry about it again? Well, when users install your app, they're greeted with this dialog, which lists all of the permissions that you've requested, along with the more user-friendly descriptions. Nothing says, This app was built by hackers who want to steal my data, rob my house, clear up my bank account, and take and share nude pictures of me, like a weather app that wants access to every permission on the device. Best practice is to request the absolute minimum of permissions. Every time you need to request a new permission, take it as a flag to stop and consider if there are other alternatives that might achieve the same goal. For example, using an intent to launch the camera app rather than accessing the camera directly. Later, we'll look at ways to share your data with other apps, using intents and content providers to create bridges between these app sandboxes. You can declare and use those permissions in these instances to similarly restrict access to sensitive information. Take a moment to explore the security section of developers.android.com. Which of these following activities can only be done after declaring a user's permission in the manifest? While declaring a permission is required for using the camera, making a phone call, or accessing contact details, you can do each of these things using a system app as an intermediator. Because the camera app, dialer, and contacts app will each be used to provide the data you request, users have the chance to cancel the action you initiated, giving them runtime ability to refuse your access. However, your app can only access the user's current location if it explicitly declares a user's permission.
Thanks, Rado. So like old times, we're going to need to ask for permission. Go ahead and change the Android manifest file to request the internet permission, and then tell us the exact string name of the permission that you used. Run the app again to ensure that it doesn't crash. You can also log the output of the network call to verify that you got the weather data back correctly. The answer is android.permission.internet. I'll show you now where it's located in the code. Under the main folder, open up the Android manifest.xml file. Within the Android manifest file, we declare user's permission with the name of the permission. We verify that the data returned is correct by adding a verbose log statement for printing out the forecast JSON string. This is in the fetch weather task. We can verify that it's going to show up in the logs. For this example, I'm going to use the command line. These are the real-time logs, and then if I hit refresh, then I see the weather data here. It's a verbose log, and this is our log tag fetch weather task. Here's the forecast JSON string, and this is all the output from the server. Great work! Thumbs up! The data has landed safely on our phones. But I was thinking about it, and actually, instead of hard-coding our postcode in, we'd really like our Sunshine app user to be able to change their location in the settings. So let's make the fetch weather task more flexible by having it take as input a postal code parameter. While we're doing that, we should also take this opportunity to do a little bit of refactoring. Instead of concatenating the strings for the server query URL, we should use a URI builder class to build up the URL. We can declare a base URL and then append each pair of query param and param values onto it. This includes params for postcode, JSON format, metric units, and day count. This will make it easier in the future if we ever have to make these options configurable by the user. If you want to verify that the URL is built up properly after you do these tasks, you can use verbose logging to print it out. In the forecast fragment, we want to modify the fetch weather task so that we can pass in the postal code parameter when we execute that task. You can click on this class to jump to where it's defined, or you can use this shortcut. And here you see that we modified the generic input type to be a string so that the doInBackground method receives string params. Now we only passed in one string param, 94043. So when you see down here later, we can read out the 0th position in the params array to get that postal code. Notice that we're using the URI builder here, and we're appending query parameters one by one. We define constants for these query params as seen here, and for the values, we also define them up here. You can imagine that in the future, these might be configured outside of this class, but for now, we're just going to define them here. To verify that this URI was built up properly, we add a verbose log command to print out the built URI. Let's verify that the log we added actually shows up. In the overflow menu, we tap refresh. Then we see the log tag fetch weather task with our URI printed out. It says 94043, JSON format, metric units, 7 days. So this looks correct. The URL that we built looks good, and the JSON string from the server also looks good. However, it still is one long string. let's look at it more carefully to see what data we should extract from it. In order to make sense of the string that comes back from the server, we can put it through a JSON formatter or a JSON prettifier. If you Google for those terms, you'll be able to find a helpful tool, such as this one. Here we pasted the result of the web query. Then it formatted the output for us, showing us the hierarchy of these elements. Now, based on the wireframes that you saw for the Sunshine app, can you tell us which of these leaf nodes we care about extracting? Even though we will have to traverse through parent nodes, for the purposes of the quiz on the next screen, we're just looking at the leaf nodes. Make your selections below on which attributes we'll need in order to display the list of forecasts. And here are the attributes we care about to display a list of forecasts in our app. For the next step, let's do an exercise that focuses on extracting out the value of one of those attributes. We're going to do this exercise a little bit differently. You'll implement this on the Udacity platform, and we'll be able to verify that your code is correct. After this video, you'll see an IDE like this, where it contains some starter code as well as some JUnit tests in a separate tab. In particular, we want you to implement this function to get the max temperature for a day. You're given a weather JSON string formatted the same way as you would get from the Open Weather Map service, and you also get the day index that we care about. Feel free to play around with the code in Android Studio or a separate development environment before you paste your answer here. Or you can use the Udacity IDE, whichever feels more natural to you. For the solution, we look for the list array. Each element in the list represents one day's forecast. Given the day index, we find the temperature node and then the max temperature. And this is what the code would look like. We turn the JSON string into a JSON object. Then we look for the list array. Within that, we find the day we care about. Then we look for the temp node and then find the max temperature. Once you've learned how to parse JSON data, it's pretty straightforward to be able to parse the rest of the fields that we need. Since this isn't a course on Java or JSON, we're going to provide you with the parsing code in the gist below. And this is what the gist looks like. There are 3 helper methods. The first is for formatting dates. The second is for rounding temperatures. The third is for turning a forecast JSON string into an array of weather forecasts. Update the fetch weather task to use these helper functions, and the doInBackground method should return a string array of forecasts. You can log the output to check that the array is correct. The format of one day's forecast should look like this. We want the fetch weather task to return an array of string forecasts. That means we need to modify the return type of the async task. Then in the doInBackground method, after we've read in the input stream, we perform this code. We call the helper method getWeatherData from JSON, and we pass in the forecast JSON string as well as the number of forecast days. We also catch any JSON exceptions if there's a problem with parsing. We wanted to verify that the string array of forecast data is correct. So within the getWeatherData from JSON method, we added some logging statements to print out each element of the array. From the logs, we know that we have the right data coming down from the server. We also verified that it's in the right format that we want as an array of strings. So now it's finally time to update the UI. Think back on when we learned about async tasks and how you can pass data back onto the main thread. Then update the array adapter with the new data from the server. As a hint, if you find that you can't access the array adapter, then check the class access modifier on fetchWeather task. Then go ahead and compile and build the app. When you run it and you hit the refresh button, you should be able to see a week's worth of data for your location. Once it's working, you can remove the verbose logging statements so you don't clutter the logs. The solution is to override the onPostExecute method of the async task, and this runs on the main thread. We receive the string array of forecast results, which came as a return value from the doInBackground method above. First, we clear the forecast adapter of all the previous forecast entries. Then we go ahead and add each new forecast entry one by one to the forecast adapter. This is what ultimately triggers the list view to update. Note that if you're targeting Honeycomb devices and above, you can use an add-all method here, so you don't have to add them one by one. You can just add it once and update the list view once. Once you hit refresh, you'll see the weather forecast for the next 7 days for your location. Even though we hit refresh, we don't have any verbose logging statements being printed out here. We don't need them anymore because we have a way to check that our code is correct by looking at the UI now. Do you remember this diagram from Lesson 1? The adapter has a reference to the raw data, and it has instructions on how to build each list item layout. These layouts eventually make it into the list view here. But what happens if any of this data changes? Let's say, for example, there's a fourth contact named Dawn. The adapter knows how to create a list item layout for Dawn. But now the list view is outdated because it only has 3 items. Somehow, we need the adapter to notify the list view that things have changed. And lucky for us, there's a method called adapter.notifyDatasetChanged. This notifies any attached observers, like this one, that the underlying adapter data has changed. Then the list view needs to populate its children again. So it asks the adapter how many items there are, and the adapter responds with 4. Then the list view goes and fetches each one individually until it fills up the screen. And it's through that method that the list view is able to get all its list items. But now you must be thinking, how did we actually update the list view successfully without adding this line of code in our app? Well, with Array Adapter, whenever you add or remove elements from it, it internally calls notifyDatasetChanged. That means we don't have to do anything. But how can we confirm this? Well, we can check the actual implementation of the Array Adapter class in the framework. And here's the code for the Array Adapter class within the Android framework. You can follow along with the link below. First, we're going to search for the add method. Remember, we added forecast strings to the adapter using this method. And sure enough, we see that the notifyDatasetChanged method is called internally. But you might be thinking, what about this Boolean here? Well, let's look it up. If you scroll to the top, you see that notifyOnChange is declared as true initially. As you go through the other references, you see that it's only changed here in this setNotifyOnChange method. Since we don't call this public method with the value false, then we know that we're going to be safely notified each time the adapter updates. Now let's go back to the add method. I want to show you one more thing. You'll notice that in the add-all method, it only notifies its observers once, whereas in the add method, every time you call this, it will update its observers. That means that our code actually is refreshing the list every time. So if you're targeting honeycomb or above, you can use this method to be a little more efficient. In general, don't be afraid to try to do this on your own. As a general pro tip, if you're ever unsure about something, feel free to go and check the Android source code. Don't treat the framework code like a black box. Take advantage of the fact that Android is open source. The more you learn about the platform, the better of an Android developer you can become. Now that our app is showing real data, we should take a screenshot of our app so we can remember what it was like when we made it this far. I personally like doing this throughout the process of building an app because then I can look back and see how it evolved. I'm going to show you one way that you can take a screenshot of your device. Open up Android Device Monitor and then click on the device here. Then click on this camera icon to do a screen capture. When it pops up, you can hit save and then you're done. On certain physical devices, there are actually hardware keys that allow you to grab a screenshot. For example, on the Nexus 5, you can long press on the volume down and the power key at the same time. That takes a screenshot. It gets saved to the Photos app, and then you can share it out to anyone you want. You can show them what an awesome app you're building. And now you're done with Lesson 2! Woohoo! You've made a huge step in being able to transfer data from a server and bring it all the way down to your device. Think about all the possibilities now of valuable information you could bring down to users to be available at their fingertips. Now that's pretty powerful. Speaking about making an impact, have you thought about what you're going to do for your final project yet? You can choose any topic that you want. Share your ideas in the class discussion forum, and you can share with your friends on social media too. Over to Rado now while I take a quick nap on this dun pillow. I'll see you in Lesson 3.
So now you've taken a UI with mock data and learned how to update it with real data. You learned how to use permissions, move time-consuming processes off the UI thread, and were introduced to the basics of network I/O. Join us again in Lesson 3, where we'll create more activities and learn how to navigate between them. But first, come with me as I take you on another voyage into the history of Android. As of July of 2013, 1.5 million new Android devices were being activated every day. So it's hard to believe that just a few years ago, I started all meetings with potential developers explaining what Android was and convincing them it was worth their time and effort developing for the platform. It wasn't until 2010 that we even shared numbers to indicate the growth of the platform, 100,000 daily activations in May of that year, which quickly grew to 500,000 in mid-2011 and crossed the million daily activations mark in 2012. That represents over 1 billion Android devices around the world, which is why I don't start my presentations asking if anyone in the room has an Android device anymore. To me though, the biggest surprise in those early days was how much effort was required to convince people that developing for mobile at all was a worthwhile investment. A huge number of people use their phones to go online, and many of them use their phone as the main way to do so. One study by the Pew Research Internet Project in 2013 found that nearly 2/3 of mobile owners use their phones to go online, double the rate found in 2009, and that 1/3 of phone users use mostly their phone to get online. Think about that for a second. These portable phones have become pocket computers constantly connected to the cloud to make the sum of human knowledge available to us at a touch and a glance. It's no wonder then that for a growing number of people, mobile isn't how to get online when you're away from your desk. It's actually displacing PCs as their primary computing platform. The change is so dramatic and the trend so clear that companies like Google, who depend entirely on the internet, have a mobile-first policy, ensuring that the mobile experience is the first consideration when building new products. This trend is particularly evident amongst younger users who grew up using mobiles, and especially in emerging markets like Africa and Asia, where the infrastructure to support ubiquitous broadband for desktops isn't as readily available. I saw this firsthand when I had the good fortune to visit Kenya a few years ago. The ubiquitous phones and passionate, talented developers were really familiar, but what really struck me was the degree to which mobile phones had become an integral part of people's everyday lives. It wasn't just checking email and posting to Facebook, it was using M-Pesa to buy everything from groceries to bus fare. Mobiles were such a part of life that I heard rather than buying someone a drink to show that you're interested, you'd send them phone credits so that they could call you if they felt the same way. And the transition of smartphones from tech accessory to a part of life to the main way you get online to how you pay for things, even how you flirt, represents a huge opportunity for us as developers. The question is, how are you going to change the world?